Hi class. In this lecture what I want to do is I want to show you an example of how to do a double integral over some general region. Okay, so here's the problem. Alright, so I want to find the double integral of 4xy over some region bounded by these graphs. Y is equal to the square root of x and y is equal to x squared. Okay, when you're given y generally, when you're given y in terms of x, this tells me it's going to be a dy dx problem. Okay, but the first thing you need to do is you need to find out your full bounds. Okay, so we know that y is going to be bounded by these two graphs somehow. Okay, I don't know which is going to be the lower bound, which is going to be the upper bound to start. And then I need to figure out what x varies from. So what you can do here generally is you can either sketch the graph or set the equations equal to each other. In this case, and set them equal to each other and solve. In this case, I found the graphs pretty easy. So the square root of x is in red here. You can see that that's this shape here. X squared is this graph here. And where they overlap or where they intersect is from x is equal to 0 to 1. And when you see that, what this is telling us is the upper bound for y is the square root of x, and the lower bound of y is x squared. Okay, so this is great then. So I've got the upper bound and lower bound for the y variable, and then for the x variable I can see that the lower bound starts at 0 and goes to 1. Great. Now I can set this integral up. So I'm going to integrate a dy dx. Okay, so what is y bounded by? Y is bounded from below by x squared and above by the square root of x. That's why the dy goes first. And then my dx, where does x go from? X goes from 0 to 1. Okay, now once you do this, this is pretty trivial. The first thing you're going to do here is you're going to integrate y, so you're going to keep x as constant. So this 4y, the x is constant, remember, we'll end up integrating as 2xy squared. Now you're just going to use your fundamental theorem of calculus to plug this in, right? So how did I get this? So when I plug the square root of x in for y, square root of x squared becomes x times x, it's me x squared. Great. When I plug x squared into y, squared squared gets me x to the fourth, times another x gets me x to the fifth. And now once you get it here, this is an incredibly trivial integral from Calc 1. They just integrate as the following here, and then this integrates as 2/3 x cubed minus, I simplified it here, this integrates as 2/6, which is 1/3 x to the sixth. Plugging in 1 here, you don't have to worry about plugging in 0 because it wipes this out. This just ends up being 2/3 minus 1/3, and my answer, final answer, ends up being just 1/3. So you can see from a problem like this, initially the integration isn't hard here. What's hard perhaps is figuring out should it be dy, dx, and what exactly are my bounds of integration. But I hope this first initial one helped you see how to approach these problems.